Hey everybody, we're going over probability once again, and we are going over experimental probability. So we're looking at usually data from a chart, from an experiment that's already taken place. So number one, what is the probability that a person chosen at random from these volunteers is between 21 and 25 years of age? So how many people are between 21 and 25? Well, it looks like 4 here, right? So 4 out of, and then when you add up all the people, that's what frequency is. It's basically how many tally marks, right? So when you add up all these people, it's 20. So 4/20ths, when you divide that by 4 over 4, is going to simplify to 1/5. So 1/5 probability that the person will be between 21 and 25. Number two, what's the probability that the person chosen will be between 31 and 35? Well, that's 5 people out of 20, which simplifies to 1/4 when you divide it by 5 over 5. Number three, what's the probability that the person will be chosen and will be over 20 years old? So over 20, that's the big thing here. These people are not over 20, so they're out. These people are not over 20. Over 20 means 21 or higher, right? So in this case, it'd be all 3 of these, so you got to add them together. So that is 10, right? That is 10 out of 20, which simplifies to 1/2. So the answer would be D. All right, next problems, we're looking at this chart from Jill, and she was picking marbles out of a bag. So based on these results, what is the probability that the next time she draws will be yellow? So how many were yellow? 2 out of how many total? Well, when you add up all those, the frequency, which is how many times she picks, there's 50 picks. So that would simplify to 1/25 after dividing by 2 over 2. Okay, number 5, what's the probability the next draw will be brown? Well, so far she's picked 22 brown out of 50, which would simplify to 11/25. C. Number 6, what's the probability the next marble she draws will not, and it's bold for a reason, right? Because they want you to pay attention to it, not white. So there are 4 white, which means how many are not white? 50 minus 4 is 46. So 46 are not white out of 50, which simplifies to 23/25. All right, D would be the answer there. All right, Maura, she surveyed 25 people in her town, and she did it at random, and she found out that 16 people were in favor of wanting a swimming pool. So 16 out of 25 people wanted a swimming pool. But we have to be careful. 16 out of 25 is there, but it says, what is the probability that the person chosen at random in the town would not favor a swimming pool? So if this many people wanted it, how many people did not want it? Well, I have to do 25 minus 16 to figure that out, and that would be 9. 9 people out of 25 did not want it. Remember, this and this, when I added those together, that'd be everybody surveyed. This is the complement. Okay, so 9 people did not want the swimming pool, 9 out of 25. All right, now we're going to look at another survey, and we're going to apply this to an entire population. So basically, Orlando surveyed 50 people about extending the school year. 12 people said yes, 25 people said no, and 13 people were unsure. So we want to know, if there's 250 people in the school, what's a good prediction of the kids that are in favor? So right now, how many kids are in favor of extending it? It would be 12 out of how many total people were surveyed here? 12 out of 50 people were surveyed said they were in favor of extending the school year. So think about what 12 is. 12 is your part, and 50 is your total. So let's come up with another fraction over here that's the same thing, part over total. But we're going to be missing part of it, okay? So the total, I know that total, there's 250 kids in the school. The part is what we're trying to figure out. So we're going to make an equivalent fraction. How many 50s are in 250? We could ask ourselves that to find out what the multiplier is. Or we could say, how many 5s are in 25? 5 times 5 is 25. So 50 times 5 is 250. So what we're going to do is multiply the top by 5 also. 12 times 5 is, well, that would be 60. So, and if you did it, 60 over 250, guess what that would simplify to? 6/25. Guess what this simplifies to? 6/25. It's an equivalent fraction, but it's just helping us make a good educated guess based on the survey that we already took. All right, so let's try another one of those here for number 10, but let's do 9 first. It says 35 out of 50 people said they'd favor school-wide student government. All right, so what is the probability that a person chosen at random in school would favor the school-wide government? Well, 35 out of 50 people said, yeah, we would support that. What would that simplify to? When you divide it by 5 over 5, you get 7/10. So 7/10 of the people said that they would favor that. Now, I'm going to bring that over here. 7/10 of the people favor a school-wide government. Now, if there's 750 kids in the school, remember, the denominator is the total. So if there's 750 kids in the school, how many people would favor a school-wide government? Let's make that equivalent fraction. 10 goes into 750 75 times. So if we multiply the top by that same 75, we're going to find that equivalent fraction, right? So I get 35, carry the 3, 49 plus 3 is 52. So 525 people would be a good estimate, okay, or a good prediction, I should say, as to how many kids would favor the school-wide government based on our survey. Okay, so we're going to get better at those. We're going to keep practicing them. And number 11, 30 people were surveyed about participating in a summer sports program. 12 said yes, 10 said no, 8 were unsure. So based on the survey, how many people will be interested? That's the important part. So 12 people were interested. They said yes. Second part is how many people were surveyed, and that adds up to 30. 12/30ths. I'm going to do this quick. I'm going to divide by the GCF, which is 6. That means I can do this in one step. 12 divided by 6 is 2, and 30 divided by 6 is 5. So 2/5 of the people surveyed, okay, chose yes. They wanted a summer sports program. All right, guys, keep getting better at this. Keep doing your best, and you can only go up. Good job, and see you next time.